Okay, welcome to joining me on another fun-filled math adventure. Work problems. Work problems are a fairly simple but easy to get complicated application aspect to rational equations. When we're looking at work problems, they can only occur in two different ways. The first way is that both objects or ideas are working together, or that they're working against each other. These are where we're talking about creating a formula where we have to use the reciprocal of the time given to complete the task. For example, if I were to tell you that it's going to take me 3 hours to, say, grade all of my math exams. If I wanted to create a work problem out of it, then I would have to turn that 3 hours into the reciprocal 1/3, and that's what I would use in order to solve my problem. So I have two examples here that I wanted to look at. One example where you have two objects working together, and another example where you have two objects working against each other. Now, in both of these problems, you are never actually going to be told this problem is working together. Instead, you have to be able to read it and recognize what the problem itself is saying. So we have, if Joanne were to paint her living room alone, it would take 5 hours. Her sister Lisa can do the job in 7 hours. How long will it take them working together? So working together is an addition problem. So we have two people. We have Joanne, who takes 5 hours to complete a job. So this is going to be the same as 1/5. Now we also have Lisa, who takes 7 hours to do a job, which is 1/7. The question is, how long would it take them to work together? So in other words, we have Joanne plus Lisa equals the job. So 1/5 plus 1/7 equals 1/x, where x is the job. Here we have to look at your LCD, which in this case is going to be 5 times 7 times x. You could also call that 35x. Either one would work. And what you have to do is first we have to start by multiplying everything by that LCD. So 5 times 7 times x. When we multiply my first fraction, the 5's go away and leaves behind a 7x. Multiplying the second fraction, the 7's go away and leave behind a 5x. Multiply the third, the x goes away and leaves behind 35. 7 plus 5 is a 12x equals 35. Divide everything by 12 and you got x is going to be 35/12 hours. Alright, the second one says, in order to flush deposits from a radiator, a drain that can empty an entire radiator in 45 minutes is left open at the same time it is being filled at a rate that would fill it in 30 minutes. How long does it take the radiator to fill? So first of all, if this were your mechanic and they did this, I would find a new mechanic. However, in a work problem, because I now have two objects or ideas that are working against each other, this one ends up being subtraction. So we have to look at, what do we know? Well, we know in order to empty your radiator, that's going to take 45 minutes, but emptying is like subtracting it away. So this would be the same as negative 1 over 45. Okay. In order to fill it, well, that is a positive thing going in, and it took 30 minutes. So filling it would be the same as a positive 1 over 30. So if we're actually looking at the basis of the problem, the base would tell us that we have to fill it minus what it takes to empty it is going to equal your job. So filling it takes 1 over 30, subtract out 1 over 45, gives you 1 over x. Again, my least common denominator is going to be 30 times 45 times x. The other way we could look at your least common denominator is we can look at what is common between 35 and 40. And in this case, what would be common there is 90. So either way you choose to use your common denominator is perfectly fine. Both of them would work. We have to be able to multiply by that common denominator. Okay. So let's say, since the last example we used a common denominator in this fashion, in this example let's go ahead and use this one. So let's multiply this by 90x. When we do that, what happens is we get 90x over 30 minus 90x over 45 equals 90x over x. And we have to go ahead and reduce. When we look at 90 over 30, this is going to become 3x. If we look at 90 over 45, this is going to become a 2x. And then here we have 90 over x, which leaves us with just 90. When we combine these, you end up with getting that x equals 90 minutes. We would get to the same answer had we used the other form of an LCD. It just might mean you would have a division step to do as well. So whether you use a common denominator or the least common denominator, you still get the same result. And this one is labeled in minutes because my problem was labeled in minutes. So in a nutshell, that's everything that you need to know about work problems in terms of applications that have a rational equation component. So if you have any questions, please make sure that you let me know. Otherwise, as always, make sure to keep smiling, ask all your questions of everybody, have tons of fun with your math, make sure you relax, and I'll see you next time.